My name is Manuel Velasquez. My project name is Recognizing Facial Expressions, and the course is CAP 4630. Objective slash motive. The goal of this project is to recognize 7 different facial expressions of a person to be able to clearly identify what the AI is seeing. This is important because it could be used to identify people and help understand situations displayed in CCTV camera footage where it can be grainy and sometimes hard to see clearly what's happening. What I mean by this is that you know how some stores, like either gas stations or like Dollar Tree, they have cameras outside, but usually the quality, or inside, and usually the quality of the cameras is very low, like very grainy, very hard to see, black and white, due to cost or storage space or whatever. This would help identify, like for example, let's say there was like a fight outside the store and somebody called the cops, and this will help cops or law enforcement or any kind of agency to help identify the expressions that both parties involved were making. So maybe the aggressor showed a very angry face or a very disgusted or surprised face. It could help identify these behavior patterns or emotions to better understand the situation when seeing it through a very poor quality of camera footage. If that makes sense. Description: what is your dataset and what kind of data are you working with? My dataset is the public facial motion dataset containing human face images. The images were labeled into 7 motion categories: angry, disgust, fear, happy, neutral, sad, and surprised. The dataset includes a variety of lighting, poses, and expressions. Images are grayscaled and low resolution to fit the scenario. The AI models I considered was the Custom Convolutional Neural Network, or CNN for short. That's what I'm going to call it from now on. And the pre-trained MobileNet V2 using transfer learning is what I used to upgrade the baseline model. And why I chose is because CNNs are well suited for image classification because they learn spatial patterns. So eyebrows, eyes, mouth, etc. They know it's easy to pick up on these things, with the facial features of a person. And MobileNet 2 was chosen because it's a bigger data set provided by Google, and it has a lot of these. It's already Basically, it's already pre-trained to identify these features of a person and what makes them unique. Uh, Data prep. The dataset already included 7 folders that had a variety of images, so it could be used to train the model. They were resized to a 48 by 48, the baseline, and a 96 by 96 using MobileNet V2. Um, Data augmentation applied to improve generalization, so rotation with slash height shift, zoom, horizontal flip. See this later. And I split the data into 80% training and 20% validation. Model training. So I trained the baseline to learn emotional features from facial images and then upgraded to a MobileNet V2 transfer learning model to boost the performance of what I got from the results slash accuracy. What MobileNet V2 is, it's a pre-trained convolutional neural network designed by Google. It was trained on ImageNet, a huge dataset of over 14 million images. In other words, it already knows how to detect facial features, making it easier to train. So it only needs to know which features matches which emotion. And I'll show this later on as well. Um, Basically, I built the baseline CNN to learn features from scratch, and then I upgraded it to the MobileNet V2, which already understands general facial structure. So I only had to train it to learn emotional differences, and I used early stopping and checkpointing to prevent overfitting and retain the best model automatically. Here you'll see the what's it called, architect or whatever, the architecture. That's the word. So for example, Con V2, it detects visual features, so like edges, eyebrows, mouth shape, etc. And then max pooling reduces image size, which while it keeps the main features intact, like stands it out. And then dropout just prevents overfitting. And then I think dense, it learns the classification patterns, so angry, upset, or surprised, it learns what each picture falls into which category. And this little snippet over here, it just showing you the code I used to upgrade it from the baseline model. Model evaluation. So the baseline model hit a accuracy of 47%, while the MobileNet V2 hit an accuracy of 49%. It hit 49, but I lost it the second time around, so it hit 40, which is weird, but alright, whatever. And I'll just read from the slides. Precision, recall, and F1 score. It detailed per class performance. The best performance the model hit was happy and surprised, so it was able to tell happy expressions and surprise expressions the best. And the weakest was fear and disgust. So basically, more subtle emotions it couldn't detect well, versus clear and more expressive emotions, like being happy, for example, was able to detect that very well. And I'll show you the confusing matrix in another slide. So these are the epochs, whatever they're called, and it shows the amount of accuracy in each time it was run through. I'll probably edit this for now, but I'll pause it from here. Intermission. Yeah, this is the accuracy and the loss on each time it was trained. I hate this so much. Okay, this is the outcome of the MobileNet one versus the regular one. The MobileNet one was cropped out a bit, but as you can see here, it was a bit more green than the regular. Let me see. Right, here we go. See, you see how it's a bit more green than the baseline because there's more red. So basically, it means T is for truth and P is for prediction. So the truth of this expression was that it was angry, and the model predicted that it was going to be angry. But you see how here this is a very angry expression, but the model predicted a neutral expression. It shows the difficulty it has to note subtle expressions in a person. This is very hard to talk. And the regular as well, you can see T is angry and P is prediction. So I got a lot of his predictions wrong versus what it actually was. Here you see the matrix for the baseline model. You see how happy it was able to predict happiness a good amount. And you'll see here you have, like, for example, surprise and disgust, a very subtle emotion, and it was like predicted like 0% of the time. And the same for the Net V2, the supposed upgraded model. It kind of just did the same, and it actually looks like it did worse than the baseline, which is a surprise. This is hard to talk. I feel so weird. Results. Baseline CNN results. The final accuracy was 47%, with strong results being happy and surprised, and weak results being fear, disgust, neutral. Before the net upgrade, the model was able to obtain a 47% accuracy rating with clear trouble identifying chaotic and subtle expressions. After the net upgrade, only a 1% increase was observed, with the same issue being present along with longer training times. This right here. 7 minutes for the base and then 12 minutes for the upgraded one. So it's not really an upgrade, but I didn't add a title. It's fine. These are the accuracy ratings. So this is the baseline. No, this is the upgraded one. So the upgraded one hit a 41% accuracy, and the baseline hit a 47%. So actually, it did worse. Surprisingly, the supposedly upgraded one was worse than the baseline. Nice. Pre-processing. Conclusion. Sorry. The conclusion is that I hate talking so much. I'll just edit this. I'll edit this out. It's fine. what I took from this. So the plan that I followed was pre-processing, training, testing, evaluation. I learned CNNs and transfer learning with mobile in V2. The model can detect strong emotions with reasonable success. It's harder for it to detect subtle expressions due to the noisy data set. So, you know, the poor quality images, it had difficulty detecting it because of the poor quality images, I assume, and the small amount of data that I use for it to train it. It shows that data quality greatly impacts AI performance, and it has is a good foundation for future improvements. So this can be improved upon immensely. So it's a good place to start from. What I would do in the future is use higher resolution RG images and collect more balanced data, bigger data set sample with better expressions and quality to compare. So I'll probably get like better images, better clear quality HD resolution images or whatever, so it can better identify which emotions it's showing on a person. Yeah, and then to show you the actual thing, it's gonna take a while for it to load, but this is like what came out. The training, the accuracies, graphs to show you. I'll just run it. Shoot. File. And it's training. It's gonna take a long time, but you get the gist. It'll go through the whole process again. That's why I showed you it the first time.